Всем привет!
Hi everyone. Before we start talking about Darknet, about Thor, I would like to ask who of you uses Tor in everyday life? Please raise your hand who uses Tor on a daily basis. So we do use Tor as well. So, for example, this is a place where I learn different admin, the botnet, different admins, search for different apps to sell the bots, some things that are not available on some ordinary forms. My colleague Masha uses as an anonymizer tool to conceal herself from different kinds of blocking system that block based on IP on or geolocation. So what do you guys do there? So those who rose your hands, just shout out. What do you guys do there? The weapons, drugs, guns, passwords. So my name is Denise, and here's my colleague Maria. We'll tell you about the things that you're actually looking on Tor. So you know this dude, right? This is Ross Walbrecht, and according to the opinion to those who employed him, he created Silk Road, and he was the admin of that forum, which was the ground number one to sell drugs, weapons, guns. So this guy earned about $200 million. But if we actually read about the consequences of the investigation, there are no technical details on how they actually got this guy, how they arrested him. So there are some details. The person simply was leaving his data or an email somewhere in public, but that doesn't explain how exactly they found the guy in a cafe where he was logged into the forum and arrested him with his bare bones. The other example is the recently closed onion resources inside of Darknet when FBI closed more than 400 different grounds related to drugs and laundry. So there are no technical details in the investigation how actually FBI got the socket and switched off the servers, but the sites were actually blocked. What can we find out from the public sources about the problems of de-anonymization of Tor users? So, just a few things. A few years ago, one person, well, he did a leak. He leaked a few documents from NSA. So what can we get from there? First of all, a few years ago they were able to tell Tor button, but now this Mozilla button is not used anymore. The guys were trying to exploit Mozilla, but it is important to know here that these kind of exploiters do not survive for long. It's easy to find them, and the number of users who apply to them is limited. Besides, they accept that they cannot de-anonymize all the Tor users simultaneously with the Tor stings. They said that they can de-anonymize only a limited amount and not on demand. So there were a few investigations when the researchers showed different channels of leaks about the person, about the Tor users, about the resident of Tor. For example, the Flash. When you watch the Flash video, there's a possibility that the channel will leak to the server, to the attacking server with the outside connection when you watch the Flash. However, the Tor developers reacted quickly and prevented Flash and canceled the Flash in the Tor browser. There's the RDC library for video streaming between two libraries. However, as a result of that video stream, the objects simply exchange their IP addresses, so the IP address can be leaked as well. So this misunderstanding was quickly fixed. So the interesting research here is the traffic analysis. Based on the traffic analysis, the guys were trying to identify the entry node of the person inside a Tor. However, all of these things require a lot of resources, a lot of firm visit nodes inside a Tor, nodes outside a Tor. So, in our opinion, the ordinary researcher would never be able to raise this kind of farm to. So this kind of research, this kind of leaks do not give an answer to the question first. How did the FBI guys find the info? They find the info of a certain forum of which, for example, only I know, or only my neighbor knows, or a few people, or just I use it all alone, like the botnet admin. And secondly, how did they find actually me, my IP address? So let us try to answer those questions. First, let's start with the passive system of traffic collection. There are a few examples here. The exit note, we wrote the exit note together with my friend Miran. Miran, if you're in the audience, please raise your hand. He promised to come and listen to my presentation. So we launched the Tor node, which had one key feature. It was able to transmit traffic through all the ports and had a sniffer. So what was the sniffer doing? It was catching all the connections, which had all the HTTP connections with a refer heading. So if the person said a Tor, click a certain link and gets to the outside web, then this package can be caught at our exit node. So we collect a lot of interesting things there, and the first thing that we found actually was very promising. So we wanted to get there some super mega private forums or the jihad sites. However, the first thing we found was this thing connecting the penis line, so I would not continue, So we were not down, we decided to continue and analyze the dump. So what we have found in the dump, a lot of black markets with different kinds of trash, a lot of markets selling the air, selling passwords, ancient databases which are considered to be leaked. So we had even hit aside the browser developers, onion resources inside the Tor. They position themselves as some unique people and get the money for simply developing the sites inside the Tor. Ordinary sites inside Tor. There were a lot of resources and passwords, so I have no idea what's behind there. We even had a Facebook, so what else to say? The sniffing and traffic on it, of course, we're not the only ones doing sniffing the traffic. There are a lot of projects. So, for example, there is a colleague in our company who does that. So he does the following: he collects onion resources and categorizes them. So we took this beautiful slide to show what kind of categories, according to his data, are present on the darknet. Of course, the biggest piece of the pie chart is the black market, and some other small things like porn, games, and stuff. So actually, passive system does not give the answer to the question how they found Loris Walbrecht and how the FBI is able to identify the IP address. Here's the concept of the active system would help us. The system that would provoke the user, the Tor, to give up some of his personal data. For example, there's a system like this. In 2014, the Leviathan security researching system found the range of exit nodes which were integrating the malicious code into the binary. But it can easily fixed by the bot who will just get through the exit nodes and as a result compare the traffic that the exit nodes give to the original dump. So the slightest difference puts the node into the blacklist. But what can we do more simple here? For example, we can identify the user by the browser. For example, fingerprinting. Here's the solution. There are a lot of projects online by which it's possible to find certain identifiers with which you can find the user, track the user, unique fields, an HTTP header, the plugins, or for example, the quantity of fonts. This works very well on normal web and ordinary web. A lot of ad agencies use that as well. However, there's no way to exploit this in Tor, a lot of these features. So, we also started to research the subject on how you can fingerprint in Tor, because it's much easier than what we have talked about. There's a certain thing called the cookie or super cookie. Those things are not saved on Tor. So in a framework 1 session, perhaps you can do that, but when you close the Tor browser, there's nothing can be done. Nothing can be done there. So there's still some peaks in Tor. So there's so-called tag canvas in HTML5, which allows to create and render the raster image and render something at the user's machine. So now this is mostly used in browser games when drawing graphics. However, this allows creating the unique data. So what do we get here? The first thing we got at the canvas that we use for fingerprinting, get image data, which was acquiring pixels of the unique image, is blocked on Tor, and we get the following notification. However, looks like this is okay. This has been closed. However, there's now the functions that are not blocked by Tor, so such as major text, which calculates the width of the rendered text in the canvas. So, as you might see in certain cases, the text might have the floating point, which actually has a lot of numbers and can be used as a fingerprint of the unique user because his rendering will depend on the software, on the hardware, and so on. So, this is not the only function that allows to get the unique identifier. For example, there's another example of the function that calculates the width of the rectangle, which is just around something, say the text, which is on the background of something. So this identifier is not blocked in Tor, and you can here get the unique number. By the way, there's just been the new update from Mozilla, and we know that the Tor browser for Windows is based on Mozilla. So this new update that unfortunately blocks this major text. So fingerprints on Mozilla is hard to do. However, in Tor browser, still this thing works. So we're waiting for this to be fixed. However, the second function, get bounding, I was talking about, it's still present in both. How come the Tor developers don't know about it? Of course they do know. Here are the screenshots of the official responses to the tickets. So, perhaps it's too small, the text. However, the response was the following. Yeah, we know about this. We could have blocked the major text and put out the window with notification, just as well that we do with other functions, such as get image data. But we do believe that this kind of approach is pointless right now because, first of all, we could get the similar fingerprint without using these functions at all, but using other technologies, even with the even numbers for the width. However, also, we globally must change the approach. We need to fix the other problem, and they refer to the other ticket, which is dedicated to the integration of the integrated fonts into the Tor browser. However, this ticket has been present for a long time, and there's a certain problem with integrating the built-in fonts. So, the proof of the concept is that the thing works. We launched the stand, we took the block here's the weekly unique visitors. So, according to this thing, 128 unique users visit the blog. So here, there's a 128 unique threads. So every visitor is indicated as thread, and I'm sure that there are 128 are potential Tor clients in this blog. So we integrate the script that does the following thing: calculates the parameter of the font and puts them down to the log. We had a lot of interesting data in that log and keep on researching it. So we see that Tor browsers launch with different virtual machines and different operating systems give the unique fingerprints, and that fingerprint doesn't change on a certain hardware, on a given hardware. So you would ask, how could that be used in the wild, in the field? We scanned over 100 web and onion resources to find web vulnerabilities, and after that, after neglecting all the false positives, we realized that the 30% of the scanned resource has allows to integrating the random JavaScript code. So the structure or the research of the FBI can get not only the exit nodes, but also all the websites and all the web resources, including the internal and external, that are vulnerable to the XSS attacks, and allowed integrating JavaScript code. So there's always an opportunity to raise a lot of doorways, a lot of websites for different subjects of these websites. They get to drugs, to cats, to guns, and get users in there. Now imagine the scenario. The user in Tor gets to the website which contains the XSS. So that website is dedicated to the drugs. So he continues surfing, and he gets to our doorway dedicated to guns, and then that person gets out into the internet, for example, gets into some LinkedIn profile or Vkontakte or some other forum, whatever. So what do we get there? There we get that behind the actual fingerprint, there's a range of psychological portrait, his history, based on which you can make a conclusion about that person. Of course, we have certain doubts that we invented this concept. Of course, probably somebody uses that already. So, question: where's the end of the anonymity in social networks? It ends where there's no JavaScript. But Masha believes differently. So let's ask her, let's ask us. Amiran, please raise your hand. You can ask him. Hey guys. So there was a question. Is it possible to save fingerprints between different browsers on one computer? No, each browser gives a unique fingerprint. However, it's saved in the browser and that hardware, and it will be unique. There were different fingerprints, but they will be unique in the framework of the hardware, on a given hardware. Question about the mega search on Tor. There are a lot of mega search engines on Tor, and they're all based in the catalog system. They're parsing the catalogs, which are inside the Tor, and just get the information from out there. So things like Google, you know, these kind of intellectual search engines, it's hard to say whether they're present or not. I don't know how they work internally, but they are parsing the catalog system for sure. On the Onion resources and stuff, that's for sure. Can I change the fingerprint? Masha, can you answer to that question? There are countermeasures to make this technique, to stop this technique from working. So one of the solutions is to integrate the built-in fonts. Just stop using the system fonts, which are dependent on the system. So then not only Tor developers are thinking of this, also the Firefox developers are thinking of this. So, as a result, all the fonts will be similar, and they will not possible to make a fingerprint. However, I should make a remark here. In theory, the fingerprint in general can be built not only based on fonts. It's just the evident thing that we see. However, there are certain ideas that this can be done based on some performance of the hardware, you know. But there's no actual proof of concept. It's too complicated, but you can dig in that direction as well. Hopefully I answered your question. Or you were asking a different thing. So what the person has to do. Sorry, I cannot hear the question, so I'm not able to translate it. So there are a lot of scenarios here. For example, you can pull the script that gets the fingerprint from you. The question is, how can you fake a fingerprint? Of course, there are callback fonts in Tor. The users make the fonts so it would be not be possible to make a fingerprint from that fonts. Can you tell about the callback fonts? Yes, there's a countermeasure, which is callback fonts. When Tor browser limits the access to fonts, limited to quantity of 10 fonts, so it can only request for 10 fonts, and all the other fonts are requested to default fonts. But that measure can actually be worked around. I will tell about it later in more detail, perhaps, because it will get too complicated. However, what the user can do, only disable JavaScript, because there's no way for user to patch the browser to make everything work differently. So, for example, the functions would be given different results. Guys, we have to run away, but not too far. We're around, so we're giving the floor to the next presentation. Thank you very much.